Welcome back to Hop into AP Precalculus. In this short video, I'll give an introduction to logarithms, and this is part of Unit 2 of AP Precalculus, which is about exponential and logarithmic functions. And then this video will mainly cover the basics, and then the next video will include more in-depth things. So why do logarithms even exist? So they are the mathematical inverse of exponents. So for example, if we have 2 to the third power, that tells us to do 2 times 2 times 2, which is 2 multiplied by itself 3 times, and that equals 8. And then logarithms are asking, to what power do I need to raise 2, which is the base, to get to 8, which is the argument? And then from here, we can see that the answer is 3. So these are the parts of a logarithm. So the way you read this expression is log base a of b equals x. And then a is called the base and x is the exponent because this can be rewritten as this expression right here. So you can see a is the base and then x is the exponent. And then when you have a logarithm, the thing that you put inside the parentheses is called the argument, and that's what you're going to be finding for how many powers you raise the base to get the argument. So now we will talk about how you can evaluate a log. So we have log base a of b equals x, so we can rewrite this as a to the x equals b right here. And then you can just think about this as doing the base to the other side of the equation equals the thing in the parentheses. So we can use that to rewrite the second equation down here. 2, which is the base, to the x, which is the exponent, equals 64, which is the argument. And then from here, we can just list out the powers of 2, which is 2, 4, 8, 16, 32, 64. So that is 2 to the 6th power, so x equals 6. And before we go on to practice, we're going to have a little exponents refresher. So if you have a to the negative m, with m being any number, that equals 1 over a to the m. So if you see a negative exponent, that means you need to make it a fraction and make it the reciprocal of what it would be. And then we have an example, which is 2 to the negative 4. So we can rewrite this using the previous rule as 1 over 2 to the 4th equals 1 over 16. And then something else is that any number to the 0 power equals 1. So a to the 0 equals 1. And then using that, we can find that 19 to the 0 power also equals 1. Also, there are two logarithms that are most commonly used, which are common log and natural log. So common log is when the logarithm has a base of 10, which is shown on the left with log base 10 of x equals y. And then natural log is when the base of the logarithm is e. So log base e of x, and that's always written as ln of x. And calculators only have these two buttons, so you can't have something like log base 2 of 8. Like the calculator won't have the buttons for you to put that in. So then you have to use a formula called change of base, which will be in the next video. Now on to some practice. So again, using the previous base and exponent thing, this is the base and this is the exponent. So 5 to the x equals 125, which is the argument. And then x equals 3. For the next one, we have 10 to the x equals 100. That means x equals 2. And then finally, we have ln of e to the 5 equals x. And then we need to remember that ln is a logarithm with base e. So this is basically log base e of e to the 5 equals x. So that means e to the x equals e to the 5th, x equals 5. So we have a couple more practices, and these will have expressions. So again, we will do base to the exponent equals the argument. 4 squared equals 2x plus 12. So 16 equals 2x plus 12. 2x equals 4, x equals 2. And the next question, we have base to the exponent. 3 to the negative 4th power equals 1 over 3x. And then 3 to the negative 4 is 1 over 3 to the 4th power equals 1 over 81. And that equals 1 over 3x. So x equals 27. And then finally, for the last one, we have 7 to the 0 power equals x. So 7 to the 0 equals x, and 7 to the 0 power is 1 because any number to the 0th power is 1. So that means x equals 1. Thank you for watching. I hope you understand logarithms better after watching this video. In the next one, I'll cover more in-depth things such as how to condense and expand logarithms, the power rule, and also change your base formula.